Hi class, welcome back. So we're gonna try another video. Here we're gonna find the horizontal and vertical asymptote where the function is defined using we'll find where the function is defined. In other words, where the domain of the function. We'll find also the holes of the function and the x-intercepts and so on. So let's jump in to this problem. We're gonna first they were asked to reduce it. So let's go ahead and reduce this. So I'm gonna say that this is if we reduce it, right? These are not the same functions, right? These behave the same way, but they're not the same functions, right? So so we can see here that these two will cancel each other out. So we would get x plus, oops, let's try this, x plus 1 to the third power and x minus 3 all to the second power. Perfect. All right, so this is the reduced form. It cannot be reduced any further. We do this by counting any common factors. So now we have to find the domain of the function. That is, the function is defined everywhere except at x. That is, x cannot equal. And to do this, what we need to do is go back to the original part of the function. The original function. Look at the original function. And determine where the denominator will be 0, right? Because the original function, that's a 6 square, that the original function looks like this, right? So the original function cannot have this equal 0, right? And cannot have this equal 0, right? Because if it does, if this is 0 and this is 0, then it will make the whole thing, the whole function, undefined, right? So in other words, what I'm trying to say here is, to find the domain of this function, we're gonna find the values of x where it cannot be, we cannot have the denominator be 0. So that'll be x plus 2 equals 0, or when x minus 3 square is equal to 0. In other words, where the denominator is equal to 0, right? And then we solve for x. So minus 2 minus 2, x equals negative 2. Again, because we have a square here, the only way that this whole thing is going to equal 0 is whenever the inside is 0. So add 3, x equals positive 3. So in other words, x cannot equal negative 2, x cannot equal positive 3, right? Because if it does, that means the function will be undefined for those. So those are the numbers that we're going to exclude from the domain. So the domain of the function is every single number, all real numbers except negative 2 and positive 3. The next one is, let's find the vertical asymptote of the function. If any, determine whether the vertical asymptote, is even or odd. So when we look at the vertical asymptote, remember that we're trying to understand the behavior of the function. So the behavior of the function will be the same whether you have the will be clear whenever we actually write it in the simplified form. So we actually want to use the simplified form. So in other words, this is going to be vertical asymptote whenever the denominator is equal to 0, right? So again, we look at the denominator equal to 0. So that would happen when x minus 3 squared equals 0. But we already know that this is going to be equal 0 whenever x equals 3, right? Because we already did that up here. So the vertical asymptote is going to be x equals 3. Now, to determine whether this vertical asymptote is even or odd, all we have to do is look at the power of the factor of that vertical asymptote. So that power happens to be a 2. A 2 is an even number. So therefore, we're going to say this is an even value. And what's important about that is because it will help us understand what kind of the shape of the graph of this one. All right, so let's jump into another one. All right, find the whole. So remember, the whole happens to be the actual value factor that was canceled. So remember that the only factor that was canceled was x plus 2. So this was canceled, so x plus 2 is set equal to 0 and subtracted. That's the whole of the function, right? Now, that's where you will find it. This is at -2, but we need to actually find it. So to find it, we need to plug it in back into the function. So please use the one that is simplified, because otherwise you're just going to get 0 over 0 on the other one. -2 plus 1 is -1 to the third, and -2 minus 3 is -5 to the second. That gives us -1 over positive 25, right? -1 to the third power is -1 times -1 times -1. And then -5 squared is -5 times -5, which is -1 over 25. Hence, the whole is -2, -1 over 25. Okay, and let's find the x-intercept. Remember what it means to be an x-intercept? It means that it's a point that is crossing the x-axis. So right here, right, somewhere in this line. So that's where y is equal to 0. So your y is 0 at the x-intercept. So x-intercept implies y equals 0. Solve for x. So finding the x where y equals 0. So you take your function, which is x plus 1 to the third, x minus 3 to the second. Remember, we said that these two have the same behavior, so same x-intercept, same y-intercept. So that means we're gonna let y be 0, right, and solve for x. So this is going to be y, so this is going to be y. This is going to be set equal to 0, right, to satisfy this condition. And then we're going to solve for x. To solve for x, the only way that this whole thing is going to equal 0, the only way this is going to equal 0, there's only one way. And that is whenever the numerator is set, when the numerator is actually 0, right? There's nothing the denominator can be. If the numerator is not 0, then the whole thing cannot be 0. So therefore, this translates to a problem of solving for x whenever x plus 1 to the third is equal to 0, which we know would happen whenever when the inside is equal to 0, which happens at x equals -1. So that's this is where it's going to happen. To find the actual point, well, we already know that when x equals when y equals 0, your x equals -1. So the point is the x-intercept is going to be x equals -1, y equals 0. Similar argument for the y-intercept. That's going to happen whenever x is equal to 0, right? If you want to find the y-intercept, you're looking for a point in the graph where it crosses this line, but for that the x value is going to be x is going to be equal to 0, right? So we're going to solve for y. So whenever x equals 0, so we're going to do the same thing. X equals 0, wherever you see an x, plug in 0 from the original function. That gives us 1 to the third, negative 3 to the second. That will give us 1 over 9. And so that means that y is equal to 1 over 9. Hence, the y-intercept is going to be 0, 1, 9. And then lastly, we're going to find the behavior of the function. And we can see that by the end behavior is by looking at the limit of the function as x approaches infinity. We can see that is going to be similar to finding the limit of x plus 1 to the third over x minus 3 to the second. Alright, so if we plug in infinity here, right, then you add 1 to infinity. Infinity plus 1 is going to be infinity. Infinity to the third, right? You have infinity to the third. Over here, you're going to have infinity minus 3, which is still going to give you infinity, which is still infinity, right? Anytime you subtract anything but to infinity, it's still infinity. And then you're going to square the infinity. So pretty much what we have is infinity cubed over infinity squared. The idea here is that they're both positive, right? They're cubed, so the idea is that these are going to cancel each other out. You're just going to be left with infinity. The other one, we'll try the same thing as x approaches negative infinity of f of x. Same idea. Infinity plus 1 is going to be infinity. And I meant negative infinity plus 1 is still going to be negative infinity raised to the third power. And then in the bottom, we're going to have negative infinity minus 3 is still going to be negative infinity. So pretty much what we have is negative infinity to the third and then negative infinity square. Well, negative infinity square, right, if you square the negative infinity, it's going to give you a positive infinity, right? So what we have here, and whenever you have a cubed of negative infinity, that will give us a negative infinity. So this is negative infinity to the third over infinity square. These are going to cancel, giving us with negative infinity. So there's no horizontal asymptote here. All right, and then we can just draw this real quick. All right, so we have division of x plus 2 times x minus 3 plus 1 raised to the third power x plus 2 raised to the second power. Alright, so let's zoom out. We can see here that there is an asymptote. Um, we can see that there's an asymptote. I mean, we're gonna have a circle, I mean a hole at -2. Okay, so that's the hole. We're gonna see the hole, and then the vertical asymptote happens at x equals -3. So if we zoom in here, we can kind of see that there's gonna be a vertical asymptote at at +3. And the end behavior, right? We can see here that this is just gonna keep going up and higher. We can't see much of that, but it's happening there, right? It's just getting up very slowly, but it's getting up right there.